So what are the most important rules regarding cooling? I would say there are two. The first rule is we want the coolant velocity to be somewhere close to the wheel velocity. So if the wheel's going at, say, 40 meters per second, we want that coolant coming out of that nozzle also going at 40 meters per second. Doesn't have to be exact. If we can get somewhere between 80% of the wheel speed to, let's say, 110% of the wheel speed, that's pretty good. That's rule number one. Rule number two is aim of the coolant. If I've got my wheel, I want the coolant nozzle and I want the coolant to hit, not up here, not down there, but right at the interface of the wheel and the workpiece, or maybe just slightly above so it hits the wheel. If I get coolant here, then the coolant maybe is within the pores of the wheel, but that wheel is going to throw the coolant off in that direction. So I want to get it right there to get coolant within the hot spot. And if I do those two things, that's usually enough to get good coolant within the pores of the wheel and get it to the hot spot. Having said that, sometimes you need good cooling, sometimes you can live with mediocre cooling, and it depends on how long the arc length is. If the arc length is long, like in creep feed grinding, we have to have good cooling because the coolant can absorb maybe 70% of the heat. If my arc length is short, like in cylindrical OD, outer diameter grinding, then the coolant can only absorb maybe 5% of the heat. Now I still need good cooling for lubrication, but I don't have to have those pores really filled with coolant. And in fact, in some applications, good cooling can hurt you because what we get is a hydroplaning force. So if I get really good coolant here and I get a lot of coolant within the pores of the wheel, I'm going to get a big force pushing up on that wheel. It might be 50 kilos of force pushing up on the wheel, which means 50 kilos of force pushing down on the workpiece. That causes deflection. And if you're trying to hold plus or minus 2 or 3 microns on your workpiece, that's going to be tough. So you have to take these situations case by case and say, okay, do I need good cooling? How am I going to do that? But then what might be some of the drawbacks of having good cooling, and how can I cope with that, say, for example, by turning down my coolant during finish grinding and spark out.